Hello everyone, this is the North American Math Contest Go Go Go. Today we are going to talk about logarithmic differentiation. Logarithmic differentiation is a type of differentiation that is able to solve problems with complex powers and square roots. So let's see. Usually when we see very complex problems like, let's say, I'm going to give you an example, x to the power of 7 times sine to the power of 6 x squared minus 1. Yeah, it is true that for this, just wait for a second. Let me add the remain quotient. And this is x squared minus 1, 10. Usually we see this problem. Yes, you can say that we can use quotient rule to solve them, but it just takes way too long time and it is very complex. So we will introduce a new way called logarithmic differentiation that can make your life easier. So basically what logarithmic differentiation is that given an equation like this, what we do is that we do ln y over ln fx to simplify the equation. Let's give you an example. Y is equal to x to the power of x. We are required to find the derivative of y prime. So how should we do that? To do that, the first thing we can do in logarithmic differentiation is that we can add the ln in both sides. So it becomes ln y is equal to ln x to the power of x, right? Recall the rule that ln is equal to log e and ln a to the power of b is equal to b ln a. This is something that you need to remember. So this means that we can simplify it into ln y, the derivative. Then we can add the derivative on both sides. So it becomes this. As they increase, as a differentiation method. So we add ln on both sides, right? We add ddx on both sides. So after we do that, we can first simplify it into x to the power of x ln x, and then we can differentiate them. So ln y becomes 1 over y times dy over dx. The right side, we can simply use the multiplication rule. So the multiplication rule is fx gx plus fx g prime x. So it is, we know that we set x as f prime x and gx. We set fx as x and gx and as ln x. So this means that f prime x is 1 over x and g prime x is equal to, fx is 1 and g prime x is equal to 1 over x. So this means that we can plug the fx and gx into this formula, which we get 1 times ln x plus fx is x times 1 over x. So it is equal to ln x plus 1 for the right side. And then what we do is that we multiply both sides by y. So it becomes y over y times dy over dx times ln x plus 1 y, right? And what we can do is that we know that y is equal to x to the power of x. So we plug the y back, which we get dy over dx is equal to x to the power of x ln x plus 1. And this is going to be our, what's that called, final derivative for the equation y is equal to x to the power of x. Let's then talk about the second example. If it's equal to ln x to the power of sine x. Again, what we can do first of all is that we can add ln on both sides. So that becomes sine x times ln x. Recall this rule. If you get confused, recall this rule. So our next task is that we can, we can continue to do the differentiation. 1 divided by x times dy over dx. For this one, we need to use what's that called a product rule again to find the derivative of this thing. I mean this specific part. So what we can do is that we can set the derivative first. Fx is equal to sine x, gx is equal to ln x. So we know that fx is equal to cosine x, gx is equal to ln x, 1 over ln x times 1 over x. Yeah. So it's 1 divided by x ln x. So what we can do then is that we can just simply time them, which is fx g prime x plus, fx g prime x plus f prime x gx. So it's sine x times 1 over ln x times 1 over x plus ln x times cosine x. And then you multiply both sides by y. And you plug y back to the what I call ln x to the power of sine x. And then you will obtain the result. The result is just going to be this. We're then going to talk about a harder example that shows the true essence on how the logarithmic differentiation, the power of logarithmic differentiation. Let's try this. Y is equal to, ln. Yeah, let me put it larger, put it in bigger form. Y is equal to ln, right? Ln x to the power of 7 sine to the power of 6x. So the above part is x squared minus 1 to the power of 5, right? And then 10 to the power of 3 x minus 1. So we have this. What we can do is that we can, we can first, we don't need to first add the ln symbol first this time. Instead, we can do something different. So we can set x to the power of 7 as a never mind. I'm going to quickly change the problem. So the problem becomes this. This is a better example. So what we can do first is that we can first change we can set them as this, and then just wait for a sec. 5 as C and 10 something as D. What we can do then is that we can add a ln symbol on both sides, so it becomes ln y is equal to, and we plug those a, b, c, d back, so it's ab divided by cd, ln a, b, c, d. And then what we can do is that ln y is become ln a plus ln b minus ln c minus ln d. And then we can plug in the a, b, c, d back. We can get ln y is equal to ln x to the power of 7 plus ln sine to the power of 6x minus ln x to the power of 2 minus 1 to the power of 5 minus ln 10 to the power of 3x minus 1. Again, just recall the rule. So we get ln y is equal to 7 ln x plus 6 ln sine x minus 5 ln x squared minus 1 minus 3 ln 10x minus 1. Yes, out of bound, but just don't care about it. You just know that this is x minus 1. What we then can do that we can just do a differentiation on both sides, so which the left side it becomes similarly 1 over y times dy over dx. And right side it becomes 7 times 1 over x, because remember that the derivative of ln x is 1 over x, plus 6 times 1 over sine x times cosine x, minus 5 times 1 over x squared minus 1. But remember, according to the chain rule, you need to do like the dx of the x squared minus 1 part again. And just wait for a sec. Minus 3 ln secant square, because remember the derivative of 10 is secant square. And you multiply those formula. What you do then you time y by both sides and you times y. So this, and then which is you plug in y with this thing. You plug in y with this thing. So the final result after multiplying both sides by y should be this. Okay, so after this video, I hope that you have some understanding about how logarithmic differentiation should work, and I hope that this skill can help you on solving the derivative problems. See you next week. Bye bye.